The Kubernetes ecosystem consists of enterprises, vendors, open source projects, and individual engineers. The Cloud Native Computing Foundation was created to balance the interests of all the different groups within the Cloud Native community. CNCF has similarities to the Linux Foundation and the Apache Foundation. CNCF helps to guide open source projects within the Kubernetes ecosystem, including Prometheus, Fluentd, and Envoy. With the help of the CNCF, these projects can find common ground where possible. KubeCon is a conference organized by the Cloud Native Computing Foundation. I attended the most recent KubeCon in Copenhagen. KubeCon was a remarkably well-run conference, and the attendees were excited and optimistic. As much traction as Kubernetes has, it still is very early days, and it was fun to talk to people and forecast what the future might bring. Two of the people I talked to were Chris Aniszczyk and Dan Kohn, who are the COO and director, respectively, of the CNCF. I was curious about how to scale an organization like the CNCF. In some ways, it's like scaling a government. Kubernetes is growing faster than Linux grew, and the applications of Kubernetes are as numerous as those of Linux. Different constituencies want different things out of Kubernetes. And as those constituencies rapidly grow in number, how do you maintain diplomacy among competing interests? It's not an easy task, and that diplomacy has been established by keeping in mind lessons from previous open source projects. I enjoy these conversations with Chris and Dan, and I hope you enjoyed them too. Azure Container Service simplifies the deployment, management, and operations of Kubernetes. Eliminate the complicated planning and deployment of fully orchestrated, containerized applications with Kubernetes. You can quickly provision clusters to be up and running in no time, while simplifying your monitoring and cluster management through auto upgrades and a built-in operations console. Avoid being locked into any one vendor or resource. You can continue to work with the tools that you already know, such as Helm, and move applications to any Kubernetes deployment. Integrate with your choice of container registry, including Azure Container Registry. Also, quickly and efficiently scale to maximize your resource utilization without having to take your applications offline. Isolate your application from infrastructure failures and transparently scale the underlying infrastructure to meet growing demands, all while increasing the security, reliability, and availability of critical business workloads with Azure. To learn more about Azure Container Service and other Azure services, as well as receive a free ebook by Brendan Burns, go to aka.ms/sedaily. Brendan Burns is the creator of Kubernetes, and his ebook is about some of the distributed systems design lessons that he has learned building Kubernetes. That ebook is available at aka.ms/sedaily. Chris Aniszczyk, you're the COO of the CNCF. Thanks for coming on Software Engineering Daily. You've been involved in a series of open source communities, most notably Linux and CNCF. How does the Kubernetes community compare to previous open source communities?
That's an interesting question. So in terms of growth, we sometimes we affectionately call Kubernetes the Linux of the cloud, right? And if you kind of saw some of the research we've done in CNCF regarding velocity of open source projects, Kubernetes comes fairly close to Linux in terms of speed and so on, in terms of like pull requests coming in, right? So it ranks, I think, number 2 behind Linux in throughput. So in terms of communities, everyone uses different tools. Linux is still old school, git format patch, mailing, LKMail is just like a bunch of patches flying through the mailing list. Kubernetes uses more modern tools. They have, stretching GitHub to the limit. So it's...
Which also happened with Linux.
Yeah.
Well, they didn't even go on GitHub, I guess.
No, Linus is explicitly anti-GitHub, or at least if he's quoted to be anti-GitHub.
But even if he wanted to be, GitHub wouldn't work for Linux, right?
It's a different workflow. Even the Kubernetes community has complaints around scaling out GitHub for its use cases, right? So they've even used they built third-party tools to help deal with the review backlog. And there's actually even startups out there like reviewable.io, which is basically helping projects that deal with just like what happens when you have thousands of pull requests? How do you know what ones you've looked at, what you haven't? And so reviewable.io is pretty cool. Highly recommend people check them out in terms of what they're doing.
Is that the code review as a service company?
Kind of. It connects directly to GitHub and it basically gives you a nice view of your backlog of reviews, and also it knows which ones you've looked at last, and it kind of tracks that, where GitHub has no concept of that. So it gives you a better interface for review backlog, and the Kubernetes community still uses it.
So you're the COO of all this madness and the chief operating officer at any company. As the company scales, the chief operating officer basically has to change their role every other week and do more things or do different things or delegate things. So how has that changed over time?
I mean, when I started CNCF, I was the founding executive director. Then, we were like 28 or so members at that time in a little over 2.5 years. We've grown as an organization. So CNCF, I think, now has 23 employees covering marketing, PR, developer advocacy, technical writing, events, a mix of everything. And so, I've shifted from executive director to COO, now managing a bunch of aspects. So it's all over. Like at the end of the day, the whole goal of CNCF is to basically support our projects, right? Essentially we're in service to our projects, and whatever their needs are, like we'll do best to accommodate that, whether it's a, new website. Some projects wanted security audits recently. So we're like, cool, like we'll go figure out how to do like third-party security audits to improve your security processes and so on. So we just react on the needs of our projects and members essentially. So yeah, it's been all over. It's kind of, it's funny. I swear to myself that I would never do like another startup, because before joining CNCF, I spent 5 years at Twitter and was there, super early, whereas maybe 100 or so engineers. Before, when I left, it was 2,000. After about 5 years, I'm like, I don't want to do that like crazy startup experience again. And then, CNCF, looks pretty good, like nice little not-for-profit foundation. And, we've grown from, 30 or so members to 216 as of today in about a little over 2.5 years. So it's just been bonkers in terms of membership growth. And even from a staff, we went from 1 to about 24 in 2.5 years.
Mm-hmm. So there are open source projects that get really big and then have organizational issues that end up, or adoption issues, or just market issues that end up making the open source project less successful than it could have been. What are the ways that what are the things that you've learned from seeing previous open source projects, and how are you avoiding that kind of problem?
When we started CNCF, we looked at other kind of open source foundations and projects and tried to take in some lessons from them of like, how can we actually build something that could learn from other people's mistakes and lessons? So a couple of things was, if you look at things like the Apache Foundation arguably has lots of great, projects out there. They have something called the Apache Way. Like every project is intended to follow the Apache Way, share the processes, governance, so on. With CNCF, we decided that's kind of limited, because each project definitely has different scope, different velocity, different levels of commitment. So we went with the bring your own governance approach. As long as you publicly document how your decisions are made and how maintainers are elected for projects, we don't necessarily care. And so it was an interesting idea, but we thought that in theory, if we allowed projects to be a little more flexible, they're not going to feel bounded by what people consider. Sometimes people are like, oh, Apache's heavyweight. So we didn't want to have that mantra of there's a lot of these heavyweight processes where most of the projects that we're taking into CNCF already were fairly functional. They just didn't maybe have their governance defined in a way that, was public and transparent and made sense so other people could join the project.
And what about testing? Because Dan was talking about testing yesterday.
Yes.
So do you enforce some kind of testing policy? No?
So the other lesson is other foundations out there, like either Eclipse or OpenStack, sometimes they do annual releases, hey, let's get all of our projects to release at the same time. We're all going to test them together. We've opted not to do that. All of our projects are kind of independently run. They define their own governance, how they run their tests, and so on. What CNCF does as a service is, if you go to cncf.ci, we have a public system out there that will take our projects, test them on all the different cloud providers out there, both public and bare metal. So AWS, Azure, OpenStack, bare metal, cloud providers pack it on bare metal and just run a battery of tests and see if it works. So we offer that as a service, but that's not a blocking thing for projects. Like they are not going to like not be able to do pull requests because their tests are failing on one cloud. So we do it as an awareness thing. We don't want to be like a gate. We just want to provide them information to see that, maybe our stuff's not working on one cloud. Why is that? We should fix that because that test is particularly red. But it's a really cool website. Highly go to CNCF CI, check it out. It's a fun project.
At this point, I have a pretty good understanding of the ways in which the CNCF is similar to a startup. What are the ways in which it is very unlike a startup?
We are a non-profit. Like everything gets reinvested into our projects,
well,
right?
Sure.
Yeah,
Organizationally.
We generally don't necessarily have a full-blown engineering team. So like we're not going to do the work that we expect our members and projects to do. What we focus on instead is things that are kind of additive and, assist projects to become easier for people to contribute to or consume. And so what that means is, what do engineers typically what they not like to do? Writing, documentation, website work, design work. So CNCF has staff that helps this for projects, right? So like we have a team of technical writers that will go out and improve our projects, documentation. We've got designers that help with website work and so on. So we help with that type of work that just makes it easier for projects to be consumed and used, but we don't actually have staff full time that is like working on like feature work for these projects.
Makes sense.
And also it would just be hard for us to compete with our members for talent, which is the other, type of problem. So
speaking of that, diplomacy is a huge aspect of your role. So you are managing diplomacy between these giant cloud providers, or maybe putting up policies within the CNCF such that you are not required to do diplomacy, like just saying, we just don't do that. We do not comment on that. You pay us money as sponsors. We give you a booth at the expo, but what's the diplomacy side of things?
So I kind of see it like, it's kind of like sports, right? Let's take soccer, for example, where, the teams are essentially the member companies all competing with each other's, and we're essentially acting as referees. So if someone, jabs someone, we call that out and do red flag or, red card, that is not allowed by the rules. So our job is basically to ensure that things are neutral and, companies are playing by the rules because they all signed up. There's a charter that dictates the values and rules of the organization that everyone's expected to follow, and we act as essentially referees to enforce, those rules amongst our members.
Has that charter had to be tweaked over time?
So in the formation and bootstrapping phase of the foundation, it took a long time to get done because anytime you're trying to build consensus with a large group of people, it takes a while. We have made some small updates over time just to fix small issues. Nothing's perfect, right? And but it's probably had 2 or 3 minor updates. But in general, the mission, the values have stayed fairly consistent. We are going through a fun process of updating the definition of what cloud native is, which is baked into the charter, and that's been kind of a fun, I don't want to say bike shedding process, but it takes a while when everyone's offered their opinion and you need to come to consensus. These things sometimes take a while.
So I've obviously heard the phrase that the goal right now is for Kubernetes to become boring, but boring in a good way because Linux is boring. People know what they're going to get from it.
So people use the word boring, but I think just like mature, something that is stable, rock solid. I don't think necessarily the technology will become boring. It's just going to become something stable and mature that's there. So it's kind of, Linux is everywhere, right? And people tend to forsake that a little bit, that it's grown so much that it's literally in almost every device we use. It's in fridges, TVs, and people didn't happen overnight. It took a long time. We essentially want Kubernetes to be something similar where it kind of falls behind the scenes, where every cloud, whether it's public or private, essentially has the Kubernetes API there and Kubernetes sitting there. So essentially from an engineering point of view, I kind of like POSIX. POSIX is something people, kind of take, for granted. Kubernetes essentially will become a distributed, API version of POSIX. So
and what happens after that? After Kubernetes is boring, then it seems like there's room for a lot of exciting stuff.
So all the fun stuff, now that we standardize on a way to do distributed development across different clouds, now we could kind of build tools. End users out there could potentially have more portable applications because, who wants to be locked into one cloud service or, provider? It's just not healthy for you. It will kill your ability to innovate, because what you want to end up seeing is all the different cloud providers and services there compete on an even playing field and continuing to better and improve things, and you have the option to move to whichever one best suits your needs as a business. And CNCF and the whole cloud native movement in general wants to enable that. Essentially, we want to enable a multi-cloud world that is fair and workloads are more portable amongst.
And do you have any more like futuristic projections? Because that's very exciting, I agree. But I asked Brendan Burns this question. He was telling me that he saw a world in which you could have a return to this static binary that you purchase, just like you used to buy a box of software off the shelf, except this time you're buying a distributed system off the shelf, and you can just go and install it on any cloud provider you want.
Yeah, I mean, that would be interesting. Like, what interests me in like kind of future directions, I would be fascinating to see like if we get to a point where you kind of have this standard distributed API everywhere, and you're essentially saying you could put constraints on a workload, right? You could be saying like, for this particular workload, I want this workload to be completed as fast as possible, and money is no object, right? And just like go, right? And then there'll be maybe a broker that goes say like, all right, we got this workload come in, like here's their kind of constraints, and then like maybe cloud providers or people bid on that. Kind of, it's like almost like high frequency trading, right?
Sounds
in
like
a way.
Ethereum.
So, I want to avoid any like blockchain related topics, but kind of like how high frequency trading works. Yeah, like we may move to a model where there's actually brokers where they'll essentially act as middlemen to compete for workloads. So
fascinating. Yeah, I think that'll happen. Just a couple more questions. So is the CNCF involved in the Kubernetes Conformance project?
Yeah, so we basically host the Conformance efforts. And
so this is like how a cloud provider builds a standard conformant form of
Correct.
Kubernetes, so that every cloud provider has some compatibility.
Correct. So
layer.
It's a working group under the auspices of CNCF that has the Kubernetes community involved in it, right? And so we've helped basically guide the process and enforce the rules that we came up to make that happen. So essentially, it's kind of cool. Like, it all lives on GitHub. So if you go to github.com/CNCF/K8S-conformance, you go there, like the tools to run the tests are all there. All the tests that we go define of what it means to be a Kubernetes certified thing are all there and documented, and everyone's open to kind of contribute to it and say like, oh, maybe we should add more tests to it, or this test is a bad one, so we can improve it. But it's all there, and you could actually see all the different cloud providers and startups that are doing cool things submit kind of their test results in real time, and kind of see, oh, great, look, like EKS maybe just certified the 110 version of Kubernetes. So it's all public and transparent, which I think is kind of cool.
Mm-hmm. So last question. I was doing a lot of reporting around the time of the whole container orchestration wars, and that was around when you were getting involved in the OCI.
So
around that time.
I am still executive director of OCI. I literally just before this, I was at an OCI face-to-face meeting. So.
Yeah. So what are your takeaways from that period of time, that arduous container orchestration war period of time?
Container wars to orchestration wars to back to container wars again, with a different kind of runtimes vying for being the de facto way Kubernetes runs workloads. It's just fascinating. So, like Red Hat's investing a lot in Creo, Docker has Containerd, Google just announced it's just fascinating to see this. So what OCI solved, in my opinion, was it got everyone in the room together and said that, like, look, this stuff has to be done in a kind of... We need to spec out what a container runtime is, what an image is. We don't want to compete at that level. It's super silly to compete on how containers are actually defined and laid out on disk. There should just be one way. Like if you essentially use a service and you build your container, you deploy it to the cloud of your choice, and then you're like, this is not good enough for me, I want to move to another one. For you to like go back and have to rebuild everything just so you can move to another service is absolutely insane, right? And so OCI basically helped prevent that issue and get the whole industry on board on speccing out what essentially, kudos to Docker, and a lot of stuff came from their technology, and spec it out and say this is the standard. It also helped neutralize patents in play. A lot of people don't realize, a lot of standards bodies have IPR agreements that all the members agree to, saying that, we're going to forego any patents that not sue each other in this space. So when OCI hit 1.0, there was an IPR agreement that said, like, anyone that is using an implementation of OCI kind of forgoes the ability to kind of sue related to patents to that specific implementation.
Awesome.
So it kind of neutralized things. It was kind of a small thing that happened behind the scenes that really kind of helped, things not turn into a crazy.
I didn't realize that side of it.
Yeah.
Well, Chris Aniszczyk, thanks for coming on Software Engineering Daily. It'd be great to talk again in the future.
Yeah, absolutely. Thanks for having me.
Okay. This episode of Software Engineering Daily is sponsored by Datadog. Datadog integrates seamlessly with container technologies like Docker and Kubernetes, so you can monitor your entire container cluster in real time. See across all of your servers, containers, apps, and services in one place with powerful visualizations, sophisticated alerting, distributed tracing, and APM. And now, Datadog has application performance monitoring for Java. Start monitoring your microservices today with a free trial. And as a bonus, Datadog will send you a free t-shirt. You can get both of those things by going to softwareengineeringdaily.com/Datadog. That's softwareengineeringdaily.com/Datadog. Thank you, Datadog. I'm here with Dan Kohn, who's the director of the CNCF, and we're at KubeCon. Dan, welcome back to Software Engineering Daily.
Thanks. Glad to be here.
So I want to start off by talking about serverless, because I've been having a lot of conversations in the hallways around serverless and how that intersects with the Kubernetes community. Why is serverless important to the Kubernetes community?
I think serverless, which is best known for AWS Lambda, has gotten a ton of people excited because it's legitimately exciting. It's a way of deploying apps that seems just easier, breaking them up than things like the millisecond billing and infinite scalability. And so what it's shown is different ways of working with computing that can just seem so much more pleasant and fast, higher velocity than what people use today. And so one of the things that we've been thrilled to see, and I love the fact that Kelsey did this demo at the end of the day, Wednesday. This is his third KubeCon that he's co-chairing and lasts for a while. And he originally wasn't sure he was going to do a demo, but he was excited enough about this cloud events work that's come out of the CNCF serverless working group that he decided to get up and demo it. And so what's been fun is to see that you can actually decompose some of those ideas that people are so excited about from AWS Lambda and then use them in different ways on other cloud providers and also on top of Kubernetes.
And one question is, if you're going to build a serverless-like platform on top of Kubernetes so that anybody that deploys a Kubernetes cluster can have serverless functionality on top of their Kubernetes resource scheduling, should that serverless functionality be bundled into Kubernetes, or should it be a world of letting 1,000 flowers bloom and having all these different serverless projects that people could deploy to Kubernetes? Does it make sense to have an opinionated way to do serverless computing within Kubernetes?
Almost certainly not. So the Kubernetes community is pretty clear about wanting to have Kubernetes do less, and they're trying to take as much code out of the project as they can. So there's a pretty active effort to try and strip out all the code from the different cloud providers and put those into separate repos so that Google and IBM and each of them don't need to make changes to the core Kubernetes in order to fix provider-specific bugs. And so by far the biggest strength of Kubernetes, in my mind, is the APIs are well regarded and have pretty clean interface points. And so it's designed as a system that you can build on top of. Now, within CNCF, I think it would make a ton of sense for some serverless projects to come in, one or more. And it's not clear yet, but there's definitely, I think at least 4 of them are presenting here at KubeCon Cloud Native Con. Kubeless, OpenFAS, Fission, and Nucleo, and I believe there's some others as well. And with the serverless working group, we created this serverless landscape, and you can see it at s.cncf.io, and then there's a link to the static version of it. And you can see that there's a lot of different options out there. But so my expectation is that they're going to build on top of Kubernetes, but that they would remain separate projects.
And serverless is appealing to me as somebody who reports on different engineering subjects because there's a lot of scheduling going on. When you spin up a serverless function, it's going to get scheduled against some opaque blob of computing, and you should be able to either say, I just want that to be scheduled and I don't really care, or you should be able to tune that scheduler how you want, which is why there's a lot of subjectivity around who builds what serverless computing framework. And I think something similar could be said about machine learning, where you have these varietal workloads. And I believe that there's some keynote talks this morning about machine learning. Are there going to be similar questions related to the ML scheduling side of things that are being asked around the serverless scheduling side of things?
I think if I had more time with a whiteboard, the one behind you, we could come up with some clever two-dimensional diagram. And so there's, at one dimension at least, is how long a function is designed to last. And so serverless is the sort of classic example where I want to resize a ping. And so, I should be able to do it in 1/100th of a second or something. But if people upload a million of them, I'd like to be able to do them all on different machines and then spin down and such. And then, so at least one axis of that is how long it lives. I think most ML workloads tend to have a much longer cycle that they want to keep living for a long time, or at least the training piece of it needs to keep going for a longer time, and then maybe the classification piece can be much faster. And so I certainly would say that the aspiration of Kubernetes and the platform that we're building is that it should support all of those workflows. And I mean, in a lot of ways, it already does. So I think there's still optimizations and tweaks and such. But in Austin 5 months ago, there was a pretty cool demo from a company, BlackRock, that was showing Kubeless, one of these offerings, running on top of Kubernetes, and that they were using that in production today. And you can say, oh, well, why wouldn't any company just use AWS or Google Functions or one of these others? But BlackRock doesn't want to use the public cloud for its internal data. And so it is pretty great that they're obviously big enough that it's pretty great that they are able to get this same functionality on their own. And they're also looking at all the ML kind of things. And so the idea that the same servers, the same resources can be scheduling all of this in an optimal way.
But the point, once again, is that this is not really something that the core Kubernetes team needs to think about as much as just their basic primitives of creating resources and scheduling those resources. They should not be thinking about, are we building resource scheduling capacity for serverless or for regular enterprises or for machine learning, cutting edge stuff. That stuff is not in their purview, right?
I mean, I think in reality, when you get to any sort of edge case, then you need to look at, are there tweaks or optimizations that are necessary? So the obvious one for serverless is that it does take Kubernetes a little bit of time to spin up a new container. And interestingly, AWS Lambda is also a container-based system, and it takes them a little bit of time to spin up a container. And so they have some tricks around warm start and hot start containers, and you can do the same thing with Kubernetes, or similar things with Kubernetes. And so as of this moment, I don't think there's any primitives missing. I think it is possible with the Kubernetes API, but it's quite likely that you need this custom resource descriptor, CRD, or other additional code. And I mean, it's early days on this stuff, so there's just a lot of innovation going on. What's nice is that if it turns out that there is an API missing or one that's suboptimal or stuff, there's a whole process in place that you could create patches and get that contributed over time.
So that cold start, hot start problem stuff, I've talked to different serverless people about this problem. Is that something where if you were running a serverless function, you would want to have something in place at a lower level of Kubernetes that actually is aware of the fact that this is a serverless function, you're solving for the cold start problem? Or is solving for the cold start problem a more general case that you would want to be solved for all containers that would be spun up on Kubernetes?
I think it's the latter. Where okay. I mean, the simplest way to think of warm start is just, are you willing to dedicate a small amount of resources to having this function in memory and ready to go so that you really can get, sub-millisecond response time the first few times you do it? So it's a set of trade-offs and knobs. But my understanding as of today is that all the knobs are currently there.
We saw the Ballerina announcement. Ballerina is this cloud-native programming language. Metaparticle was announced at the last KubeCon. Why are language-level abstractions so important?
I think I would probably generalize my answer and say that to a kind of an amazing degree, people now agree that Kubernetes will be the underlying platform for infrastructure going forward. But there is also an almost unanimous agreement that the current way of deploying applications onto Kubernetes is not going to be the winning one. It's not the optimal one. And so the idea that you need to build the container yourself and then write some YAML and push that up works great. And I mean, and tons of folks depend on it, but it doesn't seem optimal to anyone. But what there's no agreement on of any kind is, well, what should the winning technology be? And, in some ways, serverless is like a PaaS, a platform as a service. And I think one of the reasons that Heroku and Cloud Foundry excited so many people, but didn't necessarily take over the world, is that everyone wants their own PaaS, but they don't necessarily want the same PaaS as everyone else. And so one way of thinking of Kubernetes and the larger ecosystem is it's this amazing toolkit for building PaaSes. But it lets each enterprise or startup or even individual kind of customize it the way they want to. So I see Metaparticle and Ballerina, and then some others that I would put in that same category, perhaps at slightly different tiers, are some work out of Azure, Draft and Brigade, looking at how you develop the sort of closed loop cycle of making a change, pushing it up. There's a project at a company called Dataflow Telepresence that actually got submitted to the CNCF sandbox and I think is likely going to be coming in. And then some work out of Google on Scaffold and Kaneko. And these are, you actually can look on the interactive landscape, l.cncf.io, and take a look at these under the app definition and the CI/CD area. And I definitely am not making any bets on sort of what the winning technology or winning technologies would be, but it seems like an area where there's just tons of innovation going on. Each of these teams are looking at each other and saying, oh, that's a clever idea. Oh, we could implement that. But the bigger picture for me is just that everyone would like to make developers' lives easier, but not necessarily put a straitjacket on them. And so the fact that it will be Kubernetes underneath, and that at the end of the day, you can just build a container and upload some YAML if you want to, also gives you that escape hatch.
You gave a presentation earlier this week called How Good Is Our Code? Tell me the thesis of this presentation.
So the thesis is that when you look at cloud native computing, which we define as containerization, microservices, and orchestration, that actually the most important aspect of that by far is a different layer of the architecture. It's continuous integration and CI. And so and the talk will be up on YouTube, and you can link to it in the show notes. But the idea, after doing a few amusing looks at Juicero and burning trucks and rabbits and some other things, is to say, how good is our code not good enough? And so we need to have the tools and processes in place that allow us to continuously update it. And I make this point that this interactive landscape, I keep referencing it, the l.cncf.io is the example I use in the talk, is 40,000 lines of code. And that's less than 0.1% of the total amount of code that it takes to run it. And that's a huge problem because not only can there be bugs in my own code, but all of those libraries and frameworks that I depend on, Linux, Kubernetes, Node.js, Webpack, Babel, and hundreds of others can have bugs in them as well. And thankfully, there's lots of developers out there fixing the bugs, but I only get to take advantage of that if I have a way of continuously rebuilding, testing, and then redeploying my code.
Are there specific areas of the Kubernetes codebase that you're concerned about as being more untested or more raw?
That's an interesting question. So Kubernetes has a fantastic infrastructure, and I really want to credit Google here, where they have invested huge amounts of resources in the continuous integration, and it's only just now starting to get transitioned to CNCF and some of the other providers. And so they've really
had an internal continuous integration process?
Not really. I mean, it actually just uses Jenkins and it runs on Google Cloud, but it's just, they're running like millions and millions of jobs. And you can just, every time, a quick aside, when you do a pull request on Kubernetes, the Kubernetes bot writes into the pull request and says, okay to test. And then any one of hundreds of people can say, okay to test. And then the Kubernetes bot goes off and runs that code on CI. And today that's using Google's cloud resources, but we are trying to transition that and have it go through CNCF. But I mean, that's 4 years now that they've been supporting all that work. But as a quick aside, this is the first conference where we had a telepresence robot for people who couldn't be here, that you could book 30 minutes remotely on the robot. And so we called it Kubernetes bot, and there's a little tag on it that says okay to test, but it's rolling around the expo floor. And so the sort of side piece of that, one of the projects that CNCF's invested a ton into and is quite excited about is software conformance. So I'd say that one of the areas that we're particularly interested in is essentially is characterized as the external API. So not just all the internal work that all the tests are doing, but there are a bunch of conformance tests. And we now have 55 vendors that have certified Kubernetes implementations. And what it means to do that is that you use this test harness called Sonobui, and then you run the subset of tests that are conformance tests that test the external API. And if you're conformant with all of those, you upload the logs to a GitHub repo, and then we say, yes, you're certified Kubernetes. But today, those tests are not as thorough as we'd like them to be. So one of the things that CNCF has begun investing in this year with an external test development company based in Argentina is to write additional tests. And one of the changes that we were very pleased to see that the SIG architecture group in Kubernetes made is a new requirement that you can add functionality to Kubernetes, and it can get through alpha and beta, but to actually become stable, it has to include these conformance tests built into it. And so the way to think of this CNCF investment is we're backfilling some of the technical debt for existing features that didn't have conformance tests with it, but the hole won't get any deeper from here. Any new code that's contributed and gets accepted will always include those conformance tests. And hopefully we'll dig our way out of that hole before too long.
The octopus, a sea creature known for its intelligence and flexibility. Octopus Deploy, a friendly deployment automation tool for deploying applications like .NET apps, Java apps, and more. Ask any developer and they'll tell you that it's never fun pushing code at 5 p.m. on a Friday and then crossing your fingers hoping for the best. We've all been there. We've all done that. And that's where Octopus Deploy comes into the picture. Octopus Deploy is a friendly deployment automation tool, taking over where your build or CI server ends. Use Octopus to promote releases on-prem or to the cloud. Octopus integrates with your existing build pipeline, TFS and VSTS, Bamboo, TeamCity, and Jenkins. It integrates with AWS, Azure, and on-prem environments. You can reliably and repeatedly deploy your .NET and Java apps and more. If you can package it, Octopus can deploy it. It's quick and easy to install, and you can just go to octopus.com to trial Octopus free for 45 days. That's octopus.com, octopus.com. Conformance testing, for those who are unaware, meaning the Kubernetes platform that some vendor has developed is interoperable with the other Kubernetes conformant vendor-specific Kubernetes deployments.
And it connects back to the conversation we were having a second ago about deployment and development platforms, where a really simple way of thinking of it is for one of these platforms like Draft or Scaffold, and I mean, there's dozens of them. If they run on vanilla Kubernetes that you download from and install, will they run correctly on OpenShift? Will they run on GKE and EKS and all of these other platforms? And the point of this whole conformance test suite is to say yes, that all of these applications will be compatible with all the certified Kubernetes implementations.
When you think about that, 55 vendors that have been able to adopt a conformant standard, that's a pretty amazing feat of diplomacy. And that's what I think, like the CNCF is all about, these feats of diplomacy. I talked to Chris a little bit about this yesterday, and I don't think that's an accident. It seems very deliberate that as an organization, you have figured out how to maintain diplomacy among all these different organizations, these different open source projects, these developers. How have you done that? And, or more specifically, how have you avoided the pitfalls that, as humans, right, we're fallible to fighting with each other and bickering with each other and taking advantage of each other and backstabbing each other, even if we're talking about open source software. How do you avoid that?
So I definitely would say that it's probably harder than it looks. There's just a lot of telephone calls would be the simplest answer, even more than emails or GitHub issues or anything else. I will say that it is the huge strength of having a neutral organization where CNCF is part of the Linux Foundation. We're a nonprofit. There's no stock options. There's no incentives to favor one versus the other. And I think what all of these vendors are looking for is to be treated reasonably. And so we've had good luck, thankfully, on putting together a draft proposal so it was literally a year ago. It's an amazingly fast process as well. At KubeCon Berlin, I did an early morning meeting right before my keynote, and I was able to get several dozen vendors together and say, hey, here's the program we're thinking of launching. Here's our aspirations for it. Here's our process for it. Anyone was welcome to participate in it. You didn't have to be a CNCF member. And then we genuinely worked to take people's suggestions and improvements into account. And I don't mean to make it out as and then we all held hands and such. I mean, there were real disagreements along the way. But it's really one of the most amazing things I've ever been involved in my career. And so I'm incredibly grateful to all the other participants of the working group and all the vendors that have stood up. And I never imagined that it would be 55 implementations and that we would have just the entire field, I think, is the key point. There's like 5 or 6 non-certified Kubernetes out there, and they're actually here at the conference, and I keep bugging them. And there's no lack of conformance. They just haven't quite dedicated the engineering resources to finish the tests and upload them, but they all promise that they will soon.
And not to go too deep on this, but like, does this have something to do with, like, do you think changing trends in human nature or the way that the tech industry has adopted relative to, I don't know, oil companies or banks? Or not to knock on oil companies or banks.
I don't think there's definitely no changes in human nature. I think the biggest thing by far is just the advantage of CNCF coming later after other projects. And so I feel like we get to look at the mistakes that other projects and other standards efforts and such have made and learn from that. And the fact that we do try to be students of history, and our aspiration is always to get to go make entirely new mistakes and not replicate those older ones. And so, I mean, I won't name it, but I happen to know a standards effort that had a set of profiles. And one of the profiles was settings, like, do you have a settings dialog box? And then a bunch of providers came up and said, oh, look, we'll certify to the settings dialog box, and now we can claim that we're conformant with the whole standard, which is awful and a shame. But of course, the organization could have reacted to that and disallowed it and other sorts of things. But the fact that we have seen some different forms of poor behavior in the past, and that we were able to have both a stick and a carrot of saying, hey, this is a huge industry. We think certified Kubernetes is going to be an incredibly important brand, and that you want to be part of it, has been really helpful.
And so it is the carrot and the stick. It's not about the open source community as a whole having some institutional memory that, well, we've made mistakes in the past that have turned into tragedies of the commons and have led to tons of technical debt and lost business opportunities.
I think it's that. I mean, again, I don't think there's any magic that I or people at CNCF, I mean, the folks that we're dealing with tend to have the same institutional memory that we do. I mean, they're very thoughtful, engaged people. And when we can say, hey, if that proposal would lead us down this dead end, they tend to be extremely responsive.
To screw us over on.
I mean, I will just mention one innovative feature of certified Kubernetes that I'm not sure folks are as clear on. I'll actually do 2. One that's particularly neat that works for this approach is that in order to get certified, all you need to do is run this test suite. So Sonobui is the test harness, and then all these tests are already built into the repo, and upload the results. But one of the magical things about Kubernetes is that you could lie about that, right? You could just fake your logs, but then any of your users can come along at any point and rerun that test suite. And if those results were different, they could report that. Now, obviously, in most cases, it would just be a bug or some sort of incompatibility and such. And so we have a whole process in place to deal with that and give them time for adjusting it and such. But there is actually work in place to catch bad actors if that occurred. And there's a sort of distributed crowdsourcing aspect of how that works. That's very different from saying, oh, CNCF is the official testing lab and you have to send your software to us. And of course, I'm old enough to remember mailing CD-ROMs in and other sorts of things. But this is a much more modern approach. Another thing that we were genuinely worried about is someone saying a year ago, oh, well, I'm certified to Kubernetes 1.7, so I'm certified Kubernetes, and then just falling off the release train. And of course, there's so much engineering effort that's going on to add new features, to fix bugs, to improve the platform going forward. So one of the other innovative aspects of the program is that if you continue to release your product at least once a year, so 1.7, 1.11, 1.15, then all of your old certifications remain compliant. And in reality, it would be problematic after too long because the security fixes wouldn't be available. But in principle, you could backport security fixes and have much older releases on it. But in order to keep saying, oh, my older 1.7 release is certified Kubernetes, essentially you have to have a 1.11 as well. And if you don't release one within a year, then that 1.7 certification goes away. So both of those are, we think, somewhat innovative features, but it's also trying to learn from the past.
To get back to your talk, again, how good is our code? The idea that testing is really important, CI/CD is really important, even for a project like Kubernetes, or especially for a project like Kubernetes. And one reason for that is because a vulnerability in Kubernetes could be roughly as detrimental to internet infrastructure as a bug in Linux would be. So if we got one of those vulnerabilities, do you have a framework in mind for incident response?
We do, and we already did. There was one called Subpath about 2 months ago that was a very serious bug. And so the Kubernetes community has a security response team. And really the CNCF's role is we just fund some private infrastructure for them to communicate with each other. But these are some of the very top security experts from some of the biggest companies and startups around the world, and they get reports on it, and then they go investigate it, and they find patches, and then there's a release distribution mechanism. And so that piece, I mean, I certainly don't want to make it out as, oh, this is perfect and can't be improved or anything, but it's something, I mean, there's a lot of companies and a lot of money depending on Kubernetes, and so they take that work very seriously. CNCF's role there is just to facilitate it. I will mention some other work that we've done that's a little newer, where two CNCF projects, CoreDNS and Envoy, requested that we fund third-party security audits. And so we used a company, Cure53, and they went off, and CoreDNS, they found a serious bug that they fixed, but more generally they had some other suggestions and fixes. All those were taken into account, and the reports are public, so you can link to them in the show notes. But that's some work that we're interested in doing for more of our projects. I mean, security audits, they're only ever a point in time. It's still humans doing it, so there's nothing perfect about it. But we're really thrilled to be able to contribute some of the resources of our members back into those projects and to help them along. And I will say that overall, the summary of the reports were extremely positive, that they spoke very highly in terms of the quality of the code and the conscientiousness of the design, and did recommend them.
We started off talking about serverless. That's one of the I believe it's a working group, right? Yeah, it's a working group within the CNCF. And another working group that I attended a couple talks on was storage. Yes. Storage is interesting because, well, maybe you could just tell me why you believe storage is interesting. Storage on Kubernetes is interesting.
Sure. So first of all, I'll just say storage on Kubernetes, and more generally storage on distributed systems, is hard.
Yes.
So everyone agrees that stateless apps, of which serverless ones tend to be, are easier to do, and stateful ones are harder. The storage working group has unfortunately been a little contentious, And there's been sort of some innovative new startups, and then there's a lot of traditional players that are saying, hey, we want to be able to hook our big existing hardware into clusters and make that available. Thankfully, they have had some progress. There's a initiative, the Container Storage Interface, which is essentially an API. It's exactly modeled on the Container Network Interface and the Container Runtime Interface. And that's now gotten adopted into Kubernetes. I think it's beta level. But that has been some success on it. And then we do have our first project in CNCF. It's a sandbox level project called Rook, which currently takes the Ceph distributed file system, which is this decade-old piece, and then hooks it in a much more Kubernetes native way. And so I think this is one of those areas like developer tools where there's just a ton of innovation going on. I definitely don't expect there to be one solution for storage or for distributed storage, but we're sort of happy to facilitate the different players in the industry looking at different ways of working together.
Do you expect to see entirely new databases and storage styles come up, like once these primitives are built within Kubernetes, or do you think people will just start implementing things that cloud providers have?
Definitely, we're expecting cloud-native databases, and so 3 that I'll mention. Vitesse is a new incubating level project in CNCF, so relatively mature. It comes out of YouTube, where it was in production for 7 years. It's a sharding technology for MySQL. It's being used by Slack, being used by a bunch of other really interesting companies, and is a very serious solution. 2 startups that aren't involved in CNCF directly, but that we have good chats with are Cockroach Labs, which has essentially a Postgres compatible distributed database that's based to some degree on Google Spanner, and one out of Beijing that I think is very interesting called TIDB, that's a MySQL compatible API and a complete distributed one. And so I will give another quick shout out to l.cncf.io. If you go to the database and data warehouse section there, it's a little crazy that I think we're up to 39 entries, and they're of different levels of maturity and scalability and distributed, but there's tons and tons of innovation. In fact, the one last shout out I'll give out is RethinkDB, and CNCF helped get that out of Chapter 11 and get it relicensed to Apache 2.0. It's now a Linux Foundation project, but I know a lot of folks have had a good experience with that. But there are another 36 beyond the ones I mentioned.
All right. Well, Dan Kohn, thanks for coming on Software Engineering Daily. It's been really great talking to you.
You too, and look forward to seeing you in Seattle, December 11th to 13th.
Yes,
hopefully maybe in Shanghai, November 14th and 15th.
Planning on both of those.
Awesome. Thank you.
Okay, thanks, Dan. Your company needs to build a new app, but you don't have the spare engineering resources. There are some technical people in your company who have time to build apps, but they're not engineers. They don't know JavaScript or iOS or Android, and that's where OutSystems comes in. OutSystems is a platform for building low-code apps. As an enterprise grows, it needs more and more apps to support different types of customers and internal employee use cases. Do you need to build an app for inventory management? Does your bank need a simple mobile app for mobile banking transactions? Do you need an app for visualizing your customer data? OutSystems has everything that you need to build, release, and update your apps without needing an expert engineer. And if you are an engineer, you will be massively productive with OutSystems. Find out how to get started with low-code apps today at outsystems.com/sedaily. There are videos showing how to use the OutSystems development platform and testimonials from enterprises like FICO, Mercedes-Benz, and Safeway. And I love to see new people exposed to software engineering. That's exactly what OutSystems does. OutSystems enables you to quickly build web and mobile applications, whether you are an engineer or not. Check out how to build low-code apps by going to outsystems.com/sedaily. Thank you to OutSystems for being a new sponsor of Software Engineering Daily, and you're building something that's really cool and very much needed in the world. So thank you, OutSystems.
Wow.